Hi everyone, welcome back to the Controllers Knowledge. Today we are diving into the comparison of three popular TI C2000 microcontrollers, the TMS320F28335, TMS320F28379D, and the powerful TMS320F28388D. If you are into motor control, digital power, or embedded system, this one's for you. So with this video, if you are confused about which TI C2000 microcontroller is best, this video will break it down into the 28335, 28379D and 28388D microcontrollers. So the C2000 real-time microcontrollers are optimized for processing, sensing and actuations to improve closed-loop performance in real-time control applications, where the C2000 lines include the entry performance microcontrollers, that is the basic microcontrollers, and the premium performance microcontrollers. And these microcontrollers is used in industrial motor drives, solar inverters and digital power, electric vehicles and transportations, motor control, sensing and signal applications, and these are not limited. If you are looking for the core architecture, the F28335 is a single core microcontrollers, while the TMS320F28379D and 28388D microcontrollers are dual core microcontrollers with controller accelerator supports, which offering enhanced performance and capabilities for advanced control applications. So the F28335 is a single core microcontroller which supports the DMA. It is having the flash and RAM, the peripheral bus that is connected to the external peripherals, and the single CPUs. Whereas the F28379D is a dual core microcontroller with a CLI controller accelerator supports. It is having two CPUs, one CPU is the CPU1 and the second CPU is having CPU2. It is having the separate buses for the CPU1 and CPU2 and the common bus that is connected to the CPU1 and CPU2. The another advanced microcontroller, that is F28388, is having dual core plus CLI supports with the communication manager processor, that is a Cortex M4. It is having the CPU1, this is the CPU1, this is for the CPU2, and this architecture is for the M4, and all the CPUs are connected with a common bus throughout different memory management bus. So if you are looking for the feature comparisons, the F28335 is having the basic MCUs, and if you are looking for the F28379D and F28388D microcontroller, it is having the advanced microcontrollers. So these advanced microcontrollers having the more flash, more RAM, more ADC channels, more PWM channels, and the number of peripherals also increases with the newer devices. So now we will do the comparative analysis of in terms of memory, frequency, analog features, serial communication features, and many more. So the first thing we will be looking at the heart of the microcontrollers, the core architectures. The F28335 is having the single core architecture, whereas F28379D and 28388D are having the dual core architectures. And the clock frequency of F28335 is having 150 MHz, where the F28379D and 28388D is having the 200 MHz clock frequency, whereas the ARM Cortex running as 125 MHz clock frequencies. If you are looking for the floating point supports, all the MCU supports the floating point units. If you are looking for the flash size, the newer device is increasing the flash size, as you can see in the tabular, and the RAM size also increases with the newer devices. And all the MCU supports the 3 timers per CPUs, as the F28335 is having the 1 CPU, it also support the 3 timers, whereas the dual core processor also support the 3 timers per the CPUs. And the watchdog timers all are having the single watchdog timers. Now let's look into the analog features. When it comes to the analog performance, the F28335 gives the 12-bit mode, and it is having the 1 ADC with the 16 channels. And if you are looking for the speed of the sampling speed is even 12.5 megasamples per second. If you are looking for the dual core processor, is having 16-bit and 12-bit mode, the analog to digital converters, and it is having 4 ADCs. And if you are looking for the single-ended mode, it is having 3.5 megasamples per second, and in a differential mode it is having 1.1 megasamples per second speed, and that is same for the F28388D microcontrollers. If you are looking at the buffer DAC is not available in the 28335, where it is available for the F28379D and F28388D microcontrollers. Now looking for the sigma delta filter modules, that is not supported in the F28335, whereas it is supported in both the microcontrollers. If you are looking for the number of PWM channels, it is having 12 PWM channels for F28335, whereas F28379D is having 24 PWMs and 16 high resolution PWMs, whereas F28388D is having 32 PWMs and 16 high resolution PWMs. The ECAP supports is same for all 3 microcontrollers, whereas EQEP, quadrature encoder pulse support is having 2 numbers for the F28335, whereas it is 3 for F28379D and F28388D microcontrollers. And all the microcontrollers supports the 6-channel DMA control, DMA access. Now if you are looking for the communications, if you are embedded engineers, the communication is important parts for embedded engineers. So F28335 supports the serial communication, SPI, I2C and CAN, whereas the USB is supported for the advanced microcontrollers, that is F28379D and F28335, whereas CAN FD is supported in the 28388D microcontrollers, and the Ethernet is supported in F28388D microcontrollers. Now if you are looking for the trigonometric math units, the F28335 does not support the trigonometric math units, and the F28379D and F28388D microcontroller supports the trigonometric math units, and it also supports the CLB control flow accelerator blocks. So the F28379D and F28388D features the high resolution PWM for high precision control, and if you are looking for the frequency more than 200 and 300 kilohertz, the F28379D and F28388D supports the high resolution PWM features, and that provide the high precision control for your applications. If you want to looking for the communication features such as Ethernet, USB and CAN, and the CAN is supported in all the microcontrollers, and if you are looking for the Ethernet, you can go for the F28388D microcontrollers. All the microcontrollers supports the Code Composer Studio and C2000 wires and driver libraries, and with the help of system configurations tool that enhance the modern development. Now, so where you should use all the microcontrollers? So F28335 microcontrollers is ideal for the education labs, basic motor control and legacy products, whereas F28379D microcontroller is great for multi-axis motor control drivers, power converters, and real-time control with the complex maths. And if you are looking for the best IoT, industrial IoT applications, smart inverters, or any other system where real-time control and Ethernet connectivity need to work together, you can go for the F28388D microcontrollers. So to sum up with, if you are just getting started with or working on the basic control system, you can go for the F28335 microcontrollers. And if you need performance, you can go for the F28379D microcontroller. But if you want performance with the future proofing with the communications and real-time control in one chip, you can go for F28388D microcontroller, and that microcontroller is unbeatable. So let me know in the comment sections which one you are using, or if you like a deep dive into the setting of one of these up in the Code Composer Studio. And don't forget to like, share, and hit the bell icon for more embedded content. See you in the next video. Thank you.